Today's lesson is Chapter 4, Lesson 3, Solving Inequalities Using Multiplication or Division. Our essential question today is, how can you use multiplication or division to solve an inequality? So solving an inequality using multiplication or division is going to be very similar to solving an equation using multiplication or division. The key idea is right here. Multiplication and division properties of inequality, and this is for case one, or the first examples that we're going to do. And basically what it says is if you multiply or divide each side of an inequality by the same positive number here, the inequality remains true. So in this example right here, we multiply both sides of this inequality by 2. Here's a 2 and there's a 2. If we multiply both sides of the inequality by the same positive number, the inequality will look different, but it will still be true. And on this side, if we divide both sides of the inequality by a positive number, the new inequality will look different, but it will still be true. All right, so that's what we're saying there. Let's see how that is set into practice by doing some examples. So here's our first example, solving an inequality using multiplication. Let's solve x divided by 5 is less than or equal to -3, and we need to graph the solution. So I have x divided by 5 less than or equal to -3. And I'm going to solve this very much like I would solve an equation. I'm going to split up my inequality into two sides. I have x divided by 5 on one side, the -3 on the other side, with our inequality symbol in the middle. I see that my variable is being divided by 5, so in order to undo that 5 or to cancel it out, I need to multiply by 5. But I need to do it on both sides of the inequality. On this side, the divide by 5 and multiply by 5 cancels out, leaving me with just x. My inequality symbol gets brought down, less than or equal to. And on the other side, I have -3 times 5, which is -15. So x is less than or equal to -15. Now to graph, remember, we need to have a 0 on our number line as a reference point. And -15 is our starting point of our graph. That's going to be somewhere to the left of 0. Doesn't have to be on an exact tick mark here. We're just going to pick one of these tick marks to make -15. So I'll make this one here -15. Our starting point is -15, and we can be equal to it according to our inequality. So that means a closed circle. And we can be less, or we can be less than it. So it would go to the left. So our inequality, or our solution set to our inequality, is any number that's equal to -15 or less than -15, which is to the left. Now we should check our solution to see if it's correct. And that means we're going to take any number to the left of -15 and plug it in and see if it makes it true. So I have x over 5 is less than or equal to -3. I'm going to choose -20. For x, -20, because that's less than -15. It's to the left. We'll divide that by 5, less than or equal to -3. -20 divided by 5 is a negative divided by a positive, so that gives me a negative answer. 20 divided by 5 is 4. So I have -4 is less than or equal to -3. And -4 is further to the left than -3 is, so therefore it is less than -3, so that works. So I think we have some on your owns. I think I'm going to do one more with you, and then we'll go let you do the other two. So why don't I take care of number 1 here. I have n, this is a divided by 3 is less than 1. So I divide my inequality into 2 halves, and I see that my variable is being divided by 3. To undo that, I need to multiply by 3. I'm going to do that on both sides. So divide by 3, multiply by 3 cancels out. And I end up with n, bring down my inequality, less than 1 times 3 is a positive 3. So my solution is any number n that is less than 3. To graph that, I need a 0 reference point. We'll put 3 on there. 3 is our starting point for our graph, and it says n is less than 3. It doesn't say it can be equal to, so I do open circle, and n is anything to the left. Now, to check this, again, I would take a number to the left of 3 and plug it in and see if it works. So I can use 0. So we have n divided by 3 is less than 1. 0 divided by 3, if I plug 0 in, is less than 1. 0 divided by 3 is 0. Is 0 less than 1? Yes, it is. So therefore, that works. So now's the time for you to pause the video. Go ahead and take care of number 2 and 3 in the On Your Own section. When you're finished with those, restart the video and you can check your solutions. Okay, number 2, negative 0.5 is less than or equal to m over 10, or m divided by 10. So we're going to go ahead and split this into 2 parts. I notice that m is being divided by 10, so I have to multiply by 10 to undo that division, and I'll multiply by 10 on both sides. So the 10s are going to cancel out. I'm going to have on the left side, negative 0.5 times 10 is negative 5. Bring down my inequality symbol, and I have m on the right side. Now to graph this, we should remember that we should read it from the variable towards the number. So when I read that, I say m is greater than or equal to negative 5, and that helps me to graph it better. So I need a 0 reference point, and I need a negative 5 on my graph, or on my number line. And it says m can be equal to negative 5, so that's going to be a closed circle. And if I read it the way I did before, m is greater than or equal to negative 5. M can be greater than as well, so that's any number to the right of negative 5 makes it true. And if you want to go ahead and pick any number to the right of the negative 5 and check it to make sure that it works, then you can go ahead and do that. So let's just take 0 again. So I get negative 0.5 less than or equal to 0 over 10. Well, 0 over 10 is just 0. The negative 0.5 stays. So now I have negative 0.5 is less than or equal to 0. Well, any negative number is less than 0, so that must be true. All right, and number 3, negative 3 is greater than 2/3 p. So I'm going to split up my inequality. And I see that p is being multiplied by 2/3. All right. Well, so far everything's been divided by 2/3. I'm not sure why this one is here. So the way I'm going to do this is going to kind of foreshadow the next example. We're still going to undo what we see in front of us here. I see 2/3 as being multiplied by p. So what I'm going to do is to get rid of that multiplication, I'm going to divide by 2/3. Divide by 2/3. I'll be honest with you, this is a pretty bad example to stick in the section that it's in, but since it's in front of us, we're going to do it anyway. So on the left side, negative 3 divided by 2/3. I'm going to do that up here. Negative 3 divided by 2/3. That's a keep, change, flip situation. So that's equal to negative 3 times 3 over 2. In order to multiply these, I need 2 fractions, so I'll put the 3 over 1. Now I can multiply them going across. Negative times a positive is a negative. And 3 times 3 in the numerator gives me 9. 1 times 2 in the denominator gives me 2. And to simplify that, 2 goes into 9 4 times, but it's a negative 4 with 1 left over, so negative 4.5. So on this side, I get negative 4 1/2. I bring down my inequality symbol, and on this side, the 2/3 cancel out, and I just have p. If I read this from the variable towards the number, it's p is less than negative 4 1/2. So I need a 0 as a reference and a negative 4 1/2 on my number line. Since p is less than negative 4.5, not equal to it, we can do an open circle. And then it says p is less than negative 4.5. Less than means we're going to the left. All right? Again, you could plug a number in to check that. It's not required in those exercises. So to save time, I'm just going to go ahead and move forward. Example number 2 is solving an inequality using division. So again, we're going to apply the same rules. We're going to undo the things that we see. It's going to be very similar to the last on your own problem that we did, where we're going to be using division to undo multiplication. So I have solved 6x is greater than negative 18. 6x is greater than negative 18. So I divide my inequality into 2 parts. I see that my variable x is being multiplied by 6. That means I want to divide by 6 to undo it. And I'll divide by that 6 on both sides. The 6's are going to cancel out on my left side, so I'm just left with x. Bring down my inequality symbol, greater than. Negative 18 divided by 6, a negative divided by a positive is a negative. 18 divided by 6 is 3. So x is greater than negative 3. So I'll need a 0 and a -3 on my number line. And since x can only be greater than -3, it can't be equal to it, so I'll need an open circle. And greater than means anything to the right. Again, if we want to check our solution here, which is always a good idea, I can pick a number, any number to the right of -3. If 0 is one of those numbers, I like to use it because it makes it easier to do. 6x is greater than -18. 6 times 0 is greater than -18. And 6 times 0 is 0. Is 0 greater than -18? Yes, it is. Oops, that's an 18 here. All right, so 0 is greater than -18, so check that off. All right, so I'll do one more of these problems, and then you can do the last two on your own. 4b is greater than or equal to 2. Put a line down through my inequality symbol. I notice that b, my variable, is being multiplied by 4, so I'm going to divide by 4. This time I'm just going to use a little fraction bar to show division. All right, on the left, the 4 and the 4 are going to cancel out. 4 divided by 4 is 1, so that just becomes b. Bring down my inequality symbol, greater than or equal to. And then I have 2 divided by 4, which could be 0.5. Or I could just leave 2 over 4 as a fraction and simplify it, and it would be 1/2. So either 0.5 or 1/2. We do need to graph this. So again, I need 0 for a reference point. Anywhere to the right of 0, I can put a positive number. So I have 0.5. So I'm just going to put that right here to the right of 0. And b can be greater than 0.5 or equal to it. So I'll put a closed circle for equal to. And since it can also be greater than, that means we go to the right with our arrow. All right, and if I wanted to check that, which again, if I was doing a quiz or a test, I'd definitely be checking this to make sure that it's right. I could take any number to the right of 0.5 and plug it in. So I'm going to take the number 1. 4b is greater than or equal to 2. 4 times 1 is greater than or equal to 2. 4 times 1 is 4. And is 4 greater than or equal to 2? Yes, it's greater than 2. So that, in fact, worked. It made it true. So we did the problem, most likely we did the problem correctly. All right, so we got 2 more on your owns for you to do. So go ahead and pause the video, take care of these 2 problems, and then restart the video when you want to check your solution. Okay, number 5, we have 12k is less than or equal to -24. We're going to divide the inequality into 2 parts. I see that my variable k is being multiplied by 12, so I'm going to divide by 12 on both sides to undo that multiply by 12. The 12s will cancel out on the left side, and I'll have k. I'm going to keep my inequality symbol, less than or equal to, and -24 divided by 12 is -2. Go to graph that. I need a 0, and I need a -2 somewhere on my graph. And it says k can be less than or equal to. So at -2, my starting point, I'm going to put in closed circle because it can be equal to it. Or it could be less than, so it could be any number to the left of -2. And I'm going to leave that check up to you. All right? But if you got what I got, then you got the right answer. Number 6, -15 is less than 2.5q. Split it up into 2 parts. I see q is being multiplied by 2.5, so that means I'm going to divide both sides by 2.5. And when I do that on the left, -15 divided by 2.5, a negative divided by a positive is a negative, and that would be -6. And on the right side, let's bring down the inequality symbols, less than. On the right side, 2.5 divided by 2.5 cancels out, and all I got left over here is q. So I have q is greater than -6. So I need a 0, and I need a -6 on my number line. And q can be greater than -6. I'm going to read it again from the variable towards the number. Q is greater than -6, but it can't be equal to it, so it's an open circle and then to the right. All right, open circle and to the right. If you have any questions on this, please make sure you're asking in class. Be happy to go over some other examples with you. All right, now the second rule for division or multiplication, using division or multiplication to solve. And this is really important because this is where most of the mistakes in this section are made. All right. So when you multiply or divide each side of an inequality by the same negative numbers, now we're talking if we're multiplying or divided by a negative number to solve the inequality, the direction of the inequality symbol must be reversed. What that means is flipped. We must flip it over, all right, for the inequality to remain true. So let's take a look at our number examples here. In this one here, we're multiplying both sides of the inequality by -2. And when we do that, we have to flip the inequality symbol. So you'll see that the symbol here was a less than, and because they multiplied by -2, they flipped it to now it's a greater than. And when we divide by a negative number, you'll see what we divided both sides of the inequality by -2. So we started out with a greater than sign. They had to flip it to become a less than sign because we divided by a -2. The ending inequalities are still true as long as we flip the inequality symbol when we multiply or divide by a negative number. Okay, so let's take a look at some examples of that, and it might make some more sense to you. So solving an inequality using multiplication first. So let's solve -3/2 times n divided is less than or equal to 6. I'm going to be honest with you, the problem that we're looking at here for our purposes is really using division to solve this problem, not multiplication. Even though the book teaches a little differently, I want you to do it the way that we learned in class before. So I have -3/2 n is less than or equal to 6. So again, we're just going to use inverse operations. Whether it's multiplication or division, it doesn't really matter. I have -3/2 times n. So that means I want to divide by -3/2 to get rid of it. Divide by -3/2 on both sides. As soon as I see that I divided by -3/2, that should be my signal to flip my inequality symbol. In the original problem, it's a less than or equal to. I need to flip that to a greater than or equal to. We don't get rid of the equal to part. We're just really flipping over the less than or greater than part of it. All right, so I flipped it before I did any other work. -3/2 divided by -3/2 on this side is 1, so it just gives us 1n. And on this side, I have 6 divided by -3/2. All right, so that's a keep change flip situation. So that's going to equal 6 times -2/3, because I have to flip it. All right, in order to multiply fractions, I want to have two fractions to do that. A positive times a negative is going to give me a negative answer. In the numerator, I have 6 times 2, which is a 12. In the denominator, I have 1 times 3, which is 3. And I can simplify that. 12 divided by 3 is 4, so it equals -4. Okay, so that's going to come over here, -4. So n can be greater than or equal to -4. And remember, we divided by a negative number to solve the inequality, so we have to flip the inequality symbol. Now let's graph that. If we graph this, we're going to get, we need a 0 and a -4 on our number line. N can be equal to or greater than, so I'm going to put a closed circle and an arrow to the right. Now, if I want to be sure that this in fact works, I could take any number to the right of -4 and plug it in. So let's do that. -3/2 n is less than or equal to 6. I'm going to take 0, that's to the right of -4. -3/2 times 0 should be less than or equal to 6. Well, any number times 0 is just 0. So 0 is less than or equal to 6. And 0 is less than 6, so then that worked out. Right? If we don't flip the inequality symbol, let's say we forgot to flip the inequality symbol. When we go to graph this, we're going to actually have n is less than or equal to -4, and we're going to graph it the wrong direction. And if we plug in any number to the left of -4 into our original inequality, so let's say we took -6 and we tried to plug it into this inequality, we would find that it doesn't work. And that would tell us that we did something wrong. So then we should go back and check. The first thing we should check is, did we need to flip our inequality symbol? And if you did, then you should probably go back and do that. All right, I'm going to do one more of these, and then I'm going to have you do a couple on your own. So we have number 7 we'll take care of. X divided by -3 is greater than -4. Let me rewrite that down here. X divided by -3 is greater than -4. All right, I'm going to divide my inequality into two parts. I see that my x is being divided by a negative number, so I'm going to multiply by a -3 to cancel them out. So I'm going to multiply by -3 on both sides. Multiplying by a negative tells me right away that I need to flip my inequality symbol. So divide by -3, multiply by -3 cancels out to be 1, and we get x on the left. -4 times -3. Negative times negative is a positive. 4 times 3 is 12. So I get x is less than 12. Let's go ahead and graph that. I'm going to have a 0 here, and somewhere to the right I'm going to have a 12. And it says x can be less than 12. Can't be equal to it, but it can be less. So I'm going to put an open circle, and an arrow would go to the left. So I can take any number to the left of 12 and plug it back in, and it should work. So let me go ahead and do that just to double check it. So I got x over -3 greater than -4. So if I plug in 0 over -3, 0 divided by -3 greater than -4. Sorry, it's a negative. 0 divided by -3 is 0. Is 0 greater than -4? Yes, it is. So then that, in fact, is true, and we most likely did that problem correctly. All right, so there's 3 more problems here that you can do on your own, numbers 8, 9, and 10. So go ahead and pause the video, take care of those, restart the video when you're done to check your solutions. Okay, so hopefully you've taken care of doing those problems. I'm going to go ahead and do these last 3 problems quickly for you. I'm not going to do the check of the solution. Hopefully you did that, and please make sure to do that if you're doing a quiz or a test. So number 8, I get 0.5 is less than or equal to -y over 2. Now, if you remember when we were doing solving equations, this -y over 2, we always said that the negative sign really belongs with that number there. We don't want the negative with the y. We want to keep the negative with the number that's down below. So in order to get y by itself on this side, I'm dividing by -2 here, which means I want to multiply by -2 to get rid of it. So I'm going to multiply by -2 on both sides. As soon as I see that I'm multiplying by -2, I need to flip my inequality. All right, 0.5 times -2 is a -1. On this side, the -2's are going to cancel out, and all we have left is y. When I read this, I'm going to read this, y is less than or equal to -1, from the variable towards the number. So in order to graph that, which again I'll do up here, in order to graph that, I need a 0, and I need a -1 somewhere on my number line. And y can be less than or equal to it. So that's a closed circle and an arrow to the left. All right, so that's our solution for number 8. For number 9, -12 greater than or equal to 6/5 m. All right, again, this is a situation where I split this in half, and I look at this and I say, okay, 6/5 is being multiplied by m, so I'm going to want to undo that with division. So I'm going to divide both sides by 6/5. Divide by 6/5 on both sides. Now, when I look at this, I have to ask myself, did I divide by a negative number? I did not. I divided by a positive number. That means I don't flip anything. It's only if I divide by a negative number there would I flip the inequality symbol. So the inequality symbol is going to stay the way it was. All right? So I have this -12 divided by 6/5. Let's do this over here. -12 divided by 6/5. That's a keep, change, flip situation. So that's equal to -12 times 5/6. I'm going to put my -12 over 1 to make it a fraction times a fraction. And if I can, I'm going to cross cancel. So I know a negative times a positive is going to be a negative answer. And then I look at this 6 and the 12, and I can cross cancel them. They both can be divided by 6. So 6 divided by 6 is 1. 12 divided by 6 is 2. And now I can go ahead and multiply. 2 times 5 in the numerator is 10. And 1 times 1 in the denominator is 1. And -10 over 1 is just -10. So I get -10 on this side of my inequality. On the other side, the 6/5 will cancel out, and I just get m. So when I read this from variable towards number, I have m is less than or equal to -10. So I can graph that. I need a 0 and a negative 10 on my number line. M can be less than or equal to negative 10. So that's a closed circle, and less than means to go to the left. Okay? Again, read it backwards. M is less than or equal to negative 10. And I'm going to erase this right here so that I can finish the last problem. All right, so I got negative 2/5 H, less than or equal to negative 8. Okay, I see that the H is being multiplied by negative 2/5, so I'm going to divide by negative 2/5 on both sides. I notice right away that I'm dividing by a negative number to solve my inequality, so that means I have to flip my inequality symbol. Negative 2/5 divided by negative 2/5 is 1, so that just cancels out, and I have H is greater than or equal to negative 8 divided by negative 2/5. That's a keep change flip, so I'm going to do negative 8 times negative 5/2. In order to multiply these, I need the two fractions, so I'll put 8/1. It's a negative times a negative, so that's going to be a positive answer. I'm going to see if I can cross cancel. The 2 and the 8 can be cross canceled. 2 divided by 2 is 1. 8 divided by 2 is 4. So in the top I have numerator 4 times 5 is 20. And in the denominator I have 1 times 1, which is 1. And that just equals 20. All right, so H is greater than or equal to 20. I'm going to go ahead and graph that. So I need a 0. And somewhere on my graph I need a 20 to the right of 0. H can be greater than or equal to it. So I'm going to put a closed circle for equal to, and greater than would be to the right. Oops, I got some work left up there from before, so let me get rid of that. All right, this says solving an inequality using division. All right, we've already done some of that in previous examples, so we're just going to go through this problem, and you can follow along, and this should be fairly simple for you. So I get negative 3z is greater than negative 4.5. I look at negative 3 times z, so that means to get rid of that multiplication, I need to divide by negative 3 on both sides. Okay, the negative 3's cancel out, but I'm sorry, I notice that I divided by a negative, which means I automatically have to flip my symbol. Okay, negative 3 divided by negative 3 cancels out, so I get z. I got a little bit ahead of myself there. A negative 4.5 divided by a negative 3, negative divided by negative is a positive. 4.5 divided by 3 is 1.5. So my final solution is z is less than 1.5. Any number less than 1.5 should make this true. So I'm going to label a 0 and a 1.5 on my graph. Since z can be less than 1.5 but not equal to it, it's an open circle and then an arrow to the left. And in this example, we want to check our solution. So let me pick a number to the left of 1.5. Let's not choose 0 this time. Let's choose a negative number. All right. So I have negative 3z is greater than negative 4.5 was my original inequality. I'm going to choose negative 2. I get negative 3 times negative 2 should be greater than negative 4.5. Negative 3 times negative 2. Negative times negative has to be positive. 3 times 2 is 6. Is positive 6 greater than negative 4.5? Yes, it is. So we know that we've done that problem correctly. I'll do one more, and then you can solve the last 3 on your own. Let's see, which one do I want to do here? Why don't we do number 12 on this one? Nope, that's very similar to what we did. I guess they're all pretty similar. So we'll do number 12. So we got negative 2a is greater than negative 9. Excuse me. All right, so I see that my variable a is being multiplied by negative 2, so I need to divide by negative 2 on both sides to get rid of it. As soon as I see that I divided by negative 2, I should be flipping my symbol. All right. Negative 2 divided by negative 2 is 1, so that cancels out, and all we have is a on this side. Negative 9 divided by negative 2. Negative divided by a negative is a positive. 9 divided by 2 is 4 1/2. Okay, if we go to graph that, I need a 0, and somewhere I need a 4 1/2. And A is less than 4 1/2, not equal to, so it's open circle, and then arrow to the left, because less is to the left. All right, so you can go ahead and do 11, 13, and 14 on your own. Go ahead and pause the video. When you're finished with those, start the video back up and check your solutions. Okay, I'm going to go ahead and erase this so I have room to do the other problems. So number 11, we have negative 5z. It's less than 35. Negative 5 and z are multiplied, so I'm going to divide by negative 5 on both sides. You'll notice sometimes I use a division symbol and sometimes I use a fraction bar. They both do the same thing. They divide. Negative 5 I'm dividing by. That means I got to flip my symbol. So negative 5 divided by negative 5 cancels out, and I get z over here. 35 divided by negative 5, positive divided by negative is a negative. 35 divided by 5 is a 7. So z is greater than negative 7. I can graph that one down here. So I have a 0 and a negative 7 on my number line. Z is greater than negative 7, but not equal to it, so it's open circle and graph to the right, arrow to the right. All right, so number 13, I get negative 1.5 is less than 3n. So my variable's on the right side, and I see it's multiplied by 3. So in order to get rid of that, I have to divide by 3 on both sides. When I look at this divide by 3, it's not dividing by a negative number, so I don't flip my inequality symbol on this one because there's no negative that I'm using to divide it. This negative over here with the 1.5 has nothing to do with whether or not we flip the symbol. It's only whether or not this number is negative. Okay, that's what's really important. So the 3 divided by 3 cancels out, and we get n. Negative 1.5 divided by 3 is negative 0.5. Excuse me. So we're going to go ahead and graph that. Do that one here. So we're going to need a 0. And I have a negative 0.5. That's to the left somewhere. All right. And n is allowed to be greater than, but not equal to negative 0.5. So we get an open, and it can be greater than, so we can go to the right with our graph. Any number to the right of negative 0.5 will make the inequality true. All right, and all we got left is 14. So I got negative 4.2 is greater than or equal to negative 0.7w. So take a look at this problem. I see that negative 0.7 and w are multiplied, so I'm going to divide by negative 0.7 on both sides. And when I do that, I notice that I divided by a negative, which means I have to flip my inequality symbol. Now, negative 4.2 divided by negative 0.7 is going to give us a negative divided by a negative is a positive. 4.2 divided by 0.7 or 0.7 is equal to 6. On the other side, the negative 0.7s are going to cancel out, and all I'm left with is w. So when I read this inequality from the variable towards the number, it says w is greater than or equal to 6. So that's what I'm going to graph. I got a 0, I got a 6, and w can be greater than or equal to, so that's a closed circle, and it could be greater than, so that would be any number to the right of 6 would also make the inequality true. All right, so that's pretty much it for our lesson examples. On the next page here, you have some exercises that we want you to do. I think we have 6 problems that we want you to do to show that you understand what was taught in this lesson. So make sure you do these problems, bring them in, show them or give them to your teacher so that we can check to make sure that you understood the lesson. If you have any questions on the lesson, please make sure to ask when you return to class.